Okay, so the problem we're solving is to count the pairs of points with distance k. So we're given 2D integer array and an integer k, where the 2D arrays means the points in 2D plane. Okay, so we're counting the distance between the 2 points, and the distance is defined as the x1 XOR x2 and y1 XOR y2, where the goal is to return the points of pairs such that I less than j and the distance between 2 points is equal to k. Okay, so we first look at the example 1. So the distance is equals to 5, and there are 2 pairs. So the first pair is point 0 and point 1, which shows here. And if 1 XOR 4, we got 5, and 2 XOR 2 is 0. So yeah, that's correct here. And for the point 2 and point 3, we got 1 XOR 5, which is 4, and 3 XOR 2 equals 1. So 4 plus 1 is equals to 5. It's also correct here. So the method that comes up in my mind is using a brute force method. So we can first iterate through all the points, and when we check in the first point, we see the other points that we haven't seen. So by doing this, we will not do the duplicate operation here. When we see the number 1 points, we won't check the number index 0 point, because we have checking it by when we check the 0 index and check the index 1 points. So we iterate through all the points, and we check in the points that is after this point. So let's say we first n equals the length of the array, and then we iterate through all the points, where I equals the index of the points, and then the j is the points we want to check. So we will not contains our point, and we want to check the points that is after this point. So x1 y1 is equal to the first point, which is so the x1 y1 means the first point, and x2 y2 means the point we want to check. So we are now calculating the distance between these 2 points. And if the distance is equal to k, use a result here, and we can return this result. So after calculating the distance, if the distance equals to k, we add 1 into our result. Coordinates. Yeah, Okay, so we got the TLE here because the method we're using, we first iterate through n points and then we check all the points that is after this, where the time complexity is O1 squared. And this and the space complexity it's of 1 since we use some extra constant variable to handle this, and there's no extra this or dictionary here. So this method will not work here. We have to try another method. If we are adding two different number and it equals to k, we can think of like this. And since all the numbers on the points on the plane, 2D plane is an integer and it's positive, so the number of a here, so a will between 0 to k, right? So that's both of these are positive. So maybe we can try all the a's first, and then we can know if we got the first point. Let's say we have 1 point x1 y1. We want to find a desired point so that y2 so that if we do the distance operation, these 2 points match and we got the distance equals k during this operation. If this work, we will have this formula. x1 XOR x2 equals a, and y1 XOR y2 will equals k minus a. And then when we sum these up, it will equals k, which is we want here. So by doing this, based on the mechanism of XOR, S2 can be written as A XOR X1, and Y2 same can be written as K minus A XOR Y1. So these are the way we can find our desired points here. Yeah, we can move to the next step. We can first iterate through all the points here. X1, Y1 equals for and then we want to check if there are desired points for these points. How we're checking is we will iterate through all the possible A. So the possible A is from 0 to K, which is here. The range I show is here. So the desired X, which is X2 here. I'll write X2 here. and y2 here will be, like we write here, will be a XOR x1, and then y2 will be k minus a XOR y1. And then we need a dictionary to see if this point exists in our previous scene point. So if this exists, I'll use a tuple for the key of the dictionary. We add this to our result. So result equals 0 here, and then we add this to our result, and then after we try all the possible A and check is there any desired x2, y2 in for each A, we can add the point we check into the dictionary counter, which means that this point has been checked. And we can return the result here. Okay. So for this method, the time complexity is we first iterate through all the possible points, and then we iterate through all the possible A, which is k in total, k plus 1 in total. So the time complexity of this method is O(n) times k. And the space complexity, since we create a counter dictionary and we at most will add all scene points into it, so there's an extra O of n space. So space complexity is O(n). And yeah, that's it for this problem.